lesson one, page 783. The last activity. We're going to take the next few videos to go through it page by page at a time. Have something to write with, have something to write on. That, of course, is the book. The counting principle. To determine the number of outcomes in a sample space. That's a word that we've used so far. A sample space is just the entire collection of available options from that thing that's happening. To determine the number of outcomes in a sample space, you can use a mathematical principle called the counting principle. A couple of highlight times. So sample space, counting principle. The counting principle states, if an action A can occur in M ways, so 3 in my example here, and each of those M ways, action B can occur in ways, so 3 again, then action A and B together can occur in multiply M times N ways. And that's visible like in the little thumbnail up here, that 3 options for the first choice A and 3 options apiece for the second choice B result in 3 times 3. 1, 2, 3, 4, 5, 6, 7, 8, 9 different scenarios, 9 different outcomes. That is all of that. Beautiful and entirely like captured. Yes, love it. Perfect. We can generalize this to more than 2 actions, like red, blue, and then green. There's 3 and then 3 again. And then for each of those like blue options, there are 2 options apiece. So then 3 times 3 times 2 would be the multiplication principle, the counting principle that's happening. You can say M times N times S, number of ways. 3 times 2, total number of ways. Let's work this out. Let's math it out. Here we go. Devin has an all-day pass for Scream Amusement Park. His favorite rides are the Bungee Buggy, the Head Rusher roller coaster, Beep Beep go-karts, and Tsunami Slide water roller coaster. He never rides any other rides, and he can ride each of his favorite rides as many times as he wants. So if we're going to consider the situation, describe the type of event for selecting ride order. And as I think about it, these are independent. Just because you rode Bungee Buggy doesn't mean that you're going to have to then go to Head Rush. Maybe you come back and the line is short for Bungee Buggy, so you get back on it again. Therefore, what type of event? These are independent events. Independent events. Now, to explain my reasoning, I'll say it and then I'll try to write it. And then maybe you pause and skip forward 20 seconds as you write what you heard me say. They are choosing the ride to go on at this amusement park is an independent event choice, or not choice, but they're independent scenarios, independent events. Because choosing one ride or going on one ride does not influence the next ride that Devin will choose to get on. Oh, and repetition is allowed. Ride choice does not influence the next ride choice. Doesn't have to. I know when we go to to a carnival or to the fair or to an amusement park, we think, I got to ride that big roller coaster, and then I want to go ride the next ride, and then I want to go ride the big roller coaster again. So you're planning out your process. But that doesn't mean that just because you did go big roller coaster first means you have to go to the water coaster next. Okay, also repetition is allowed. Use the counting principle to determine the number of possible ride orders for Devin's next 2 rides. So, counting principle says how many choices are available in the first action. So in action A, how many choices are available? Buggy and Head Rush and Beep Beep and Tsunami. There are 4 choices, 4 options. Options is a better word. So he goes and he picks one, right? Down that path. And then after the ride is over and he's at the end of okay, I went on that ride. Now what? He still has 4 choices available because, You don't eliminate a choice. An option. You don't eliminate an option. Okay. So if there are 4 options in the first action and then second ride, second action, there are still 4 options. That means he has a combined total of 16 total scenarios that he could explore the park in that, or 2-ride order. How many order possibilities are there for Devin's next 5 rides? All right, so 4 and 4 again, and 4 again, and 4 again, and 4 again, and you multiply. So if there's 4 rides, you can repeat, get on the same ride again, but you had the choice out of 4 to go on. 4 more options because you're doing the same scenario again, 4 and 4 and 4. So a total of 4 times 4 times 4 times 4, 5 times. Or in other words, 4 to the exponent of 5, 4 to the power of 5. Hey Siri, what's 4 to the 5th power?
The answer is 1024.
1024. So he has 1024 different ways to choose his path, or to follow his path through the different coaster rides at the amusement park. Now, they might not all be the same, right? He might ride the same ride 4 times, 5 times in a row, but that's only one way that he could have approached the rides that he has available to him at the park. When you start to add more and more choices, we get a broader arrangement of possibilities. Some of them not interesting, some of them not interesting at all, but the options available in comparing all of them all at once can be a large amount of choices. Thank you for watching page 783. 784 is next. A little preview on page 784 is that we will talk about another scenario of the counting principle. We're talking about options that are available to a student's daily schedule. Some of you at this time of the year might have chosen your classes for the next school year, and you're wondering if you made the right choice and picked the right options. Well, there are many different combinations that you could have chosen from, and we'll continue exploring that in the next activity, the next part of this lesson. Thank you for watching this video, liking, commenting, and subscribing, haha, whatever that works for, and I'll see you in the next episode.